Alright, hello flippers, this is video 8.7 and the unit title is Shadow Proof, and the objective is students will be able to use the properties of cylinders and cones to solve volume problems. And your IQ skills are T4 and T5. These are a really great review of all the volume problems we've been doing, so go ahead and knock those out. Try and get at least an 80. Alright, let's go flippers. So far with volume, we've actually looked at volume in terms of what it is. So volume is the measure of cubic units. Right, so if you think of those 1 by 1 by 1 unit cubes that we've been actually using in class all year, think about those cubes we've been using. Okay, it's the measure of how many of these can actually fill into any object. Okay, and so far we've looked at two particular cases. We've looked at prisms, which you can see here. Here's a prism. I'm outlining it here. It's the white glass structure. Here's another prism. Here's another prism. And we've also looked at pyramids. And you can see there's a pyramid, there's a pyramid, there's a pyramid. And if we look at this really closely, we'll remember that the prisms, so this prism in particular here, it tells us that the prism's volume is actually 12. And we know that because it's the volume is calculated by looking at the area of the base. So the area of the base here is a 2 by 2, so it's 4, and then times the height. So that gives us 12 units, 12 meters, cubed. New stylus, guys, new stylus, trying to make it work, okay? It says 12 meters cubed. So again, that was the area of the base. 2 times 2 is 4, times the height of the prism, which is 3, which gave us 12 meters cubed. Now for the pyramid, well, they tell us that the pyramid's volume for this first one is 4. Now if we compare 12 to 4, we know that that is actually 1/3. So 12 divided by 4 is actually 3, which tells us that this pyramid here, like most pyramids, all pyramids actually, would actually be 1/3 the volume of the prism with the same measures of the base, area of the base, and the same height. So this is really important because in order to figure out the area of the volume of the prism, what we need to do is we'd actually take the same area of the base, which would be 2 times 2. So 2 times 2, which will give us 4, times 3, and that's the height. And we divide all of that by 3 because remember, this pyramid is 1/3 of the prism. And that would give us 4, right? Because 4 times 4 is 3. 2 times 2 is 4, 4 times 4 is 3, which would be 12 over 3. And 12 over 3 divided by 12 divided by 3 would give us 4 meters cubed. Yeah! All right. And if we looked at all the rest of these, we would see the same comparison. So let's look at them quickly. We've got a prism here, which is 6. Okay, that's its volume. The pyramid inside of it, hey, look at that, 2. 6 divided by 2 is 3. Same idea. The prism here, volume is 18 meters cubed. And look at that, the pyramid inside of it is going to be 6 meters cubed. Again, 18 divided by 6 is going to give me 3. So it's the same idea of if I've got the prism, it's going to just be, again, the area of the base times the height. But then if I have the pyramid, it's going to be that same thing except divided by 3 because 3 fit in there. So the reason why we looked at that is because we're going to now explore another set of figures that work similarly. Okay? Now we know that we don't always have figures that have these polygonal faces, right? We have to have figures that curve. Otherwise, we can't have beautiful soup. Right? We can have lovely soup cans and tuna fish and all those awesome things. So there's a figure called a cylinder. Okay? And we've actually looked at the surface area of a cylinder by unfolding it and making a rectangle and then a circle on top and a circle on bottom. You guys are really good at that. So now what we want to do is we want to look at how we'd actually fill the can of soup. Like how much soup is actually in one of those Campbell soup cans, right? Or maybe Progresso or all those yummy cans. Anyway, so let's actually look at a cylinder itself. So if a cylinder works similarly to a prism, so there's the prism up there, there it is, and here's the cylinder down here. So let's just think about something. Volume works the same exact way. Volume for a cylinder is literally going to be the same thing. It's going to be the area of the base, which we see is a circle. So we'd say the volume is going to be equal to, and let's give this radius, let's make it 4, okay? So we'll say it's going to be equal to the area of the base, which in our case is a circle with a radius of 4. So we'd say the pi r squared, because that's how you find the area of a circle, and then times the height. And then over here we're going to give this cylinder a height, so we'll give it a height of 7. So then we'd multiply by the height. So we'd actually fill this in. We'd say pi, and then we put 4 squared because that's the radius, and then we multiply that by 7. We'd end up with 16 times 7 times pi, and then to simplify that, so that's going to give me 112 pi, and we'll make this units, and it's cubed. So now I want you to think about something else. I can take, and you want to read this with me here. It says it takes 3 cones to fill a cylinder with the same radius and height as the cone. So think back to our pyramids. Remember, we'd have a pyramid, and there one is right there. Sorry about that. There one is, right? The pyramid's fitting right inside of that prism. And remember, it's 3 of these that can actually fit in there. Same idea is happening with the cones. 1, 2, 3 of these it will take to fill up this actual cylinder to the top, which means that the volume of a cone, dun, 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 you're probably guessing it, is going to be so similar to the volume of a cylinder. You're going to take again the area of the base, which would be, the base here is a circle, and that's pi r squared. Again, we put an r there, times the height, and the height would be here. They'd have to tell you what this height was. And remember, you want the height, so you're going to get that tallest segment from a point on the base to the apex of that cone, okay? And you're going to multiply it by the height. And the last thing, because again, the 3 of these fit in, 1, 2, 3, you're going to divide by 3. If we took this same problem that we had over here where we got 112 pi units cubed, we could just take that number, so 112 divided by 3, and then we could add to that pi units cubed. And that would actually be the volume of one of these cones. All right, let's look at one example here. So example number 1 says, guess which jar holds the most jelly beans and win the jar. Wow, is it jelly bean? Is it jar 1, 2, or jar 3? The way we see these are cylinders, we should be able to figure out the volume of cylinders. So we're going to go ahead and say, again, the volume is going to be equal to the area of the base. I know that the base here is a circle. So I'm going to say that that circle's area is pi times the radius, which is 6 squared, times the height, which is 2. And I'm going to do the same thing for the next 2. So there we have it. For the second equation, we've got volume equals pi 4 squared times 4. And the third one, pi times 2 squared times 8. And again, that was my base here, my base here. So let's finish the calculations. We've actually gone ahead and figured out what the volume is in pi, right? And we haven't added units yet. So let's actually round this to the nearest tenth, because that's some good practice. So what you actually do is you take the number, you multiply it by pi in the calculator, actually pi, and then I want you to round it to the nearest tenth, and that's what I'm asking you to do. Before you do that, go ahead and guess jar 1, jar 2, jar 3. I'm going to guess jar 2. Yes, I want to guess jar 2. When I got 226.19, but I say around to the nearest tenth, so that's 0.2 centimeters cubed. For the second one, I'm getting 201.06. We're going to round that to the nearest tenth, so that'll be 0.1 centimeters cubed. And for the third one, it's 34 times pi, which is going to be about 106.8 centimeters cubed. And it looks like the jar with the most, is jar 1. So I didn't guess right, I lost. I'm sad. Who talks about a teepee. So let's actually draw a teepee. It says a child's teepee is 6 feet high with a radius of 3.5 feet. So here's the teepee. Oop, I'm drawing it upside down. Let me draw that correctly. So the teepee, right, when I want the child to like be lying in the air. So here's the TP, beautiful TP. The radius is 3.5, and the height is 6. Okay, so what we're going to do here is, I know you see a solution, and this is how traditionally it gets solved, but I want you to think about it in terms of a cylinder. So if you can imagine that this TP was inside of a cylinder, okay, and the cylinder has the same area of its base and the same height as the cylinder. So what we're going to say is, let's just imagine we're finding the volume of a cylinder, which will be the volume equals the area of the base, which is pi r squared. So we've got pi, and then r is 3.5. We need to square it, and then times the height, which would be 6. Now, remember, this is a cone, and we know that there are 3 of these. Remember, there were 3 of these cones before, so we'll take 1, 2, 3 to fill up this entire cylinder. So the actual measure, or the volume of the cone inside, is actually going to be divided by 3. So we only need a third of that cylinder. So now we actually calculate this. We have pi times 12.25 times 6 times 3. Okay, we're going to keep the problem going over here, and we want to know what is 12.25 times 6, and we get, now we've got 73.5, and we have to divide that by 3. So let's do that. And we're going to end up with 24.5, and we have to multiply that by pi. Let's do that. Lo and behold, they wanted to the nearest cubic feet. It ends up being 76.9, and say they want cubic feet. So we round this to, and I'm going to write my answer up here because I ran out of room, 77, and this was feet and cubed. Okay, so again, they have the same answer we do. Hooray, that's a good thing. But again, it's the way we got our answer. Secret hot question. It's got 3 parts. Yeah. Okay, so the first part says, find the volume of the cone. So there is a cone in there. Then it says, find the volume of the cylinder. Ooh, you get to find the volume of the cylinder. And then it says, determine the volume in the cylinder that is not occupied by the cone. So you're looking for all of the space in the figure that is here. Right? You're looking for all that space. Like, how much space is occupied? How would you figure that out that is not occupied by the cone? See you guys on Monday.